Welcome back to your MATLAB mentor, where MATLAB turns math into motion. Let's go to smarter, not harder. Opening up a new episode, today we'll continue our talking about another several topics, so please make sure that you have been watched all the previous episode as they are all depend on each other. Today gonna be very interesting episode because we're gonna take many functions but to completely next level. So the episode today will be in a way that we do right task and then we're gonna answer those tasks. So it's just helping you to use different functions and applying them as we go. So let's start. So the first task that we do have will be read. So right there in my current folder I do have seasons data. So the first task will be reading this file. So read the seasons data file into MATLAB. So as I said, I do have the folder in my I do have the file in my folder. So right now I have just to create a variable. Let's make like this season n maybe, and then equal. So this is the name of the variable. Now MATLAB do expect me to find a function to read this file. So this function is read table, and we did explain this in the previous episode, so you might see this as a recap, but it's very helpful because it's gonna enforce this in your mind, so you're gonna be better with it. And then if I open a bracket, I already have a recommendation of the files that I do have. So this season data, this is the file I do want. Okay, and then I will press run or run section. And as we mentioned before, run section, I'm gonna just run the section under the double percent run. It will run the entire code that I do have. So here we go. Now I do have a file called season n. If I open a season n, like a lot of rows, a lot of columns, but yeah, then like I did finish the first task. And as I said, MATLAB function is very straightforward. Read table is just to read tables or read this file, because basically this file is a table. So read table is just to read table. Okay, so next task. Now extract the time and temperature from the table. Okay, extract the time and temperature. Time, we in the previous episode we explained time data and how I can like represent my time in a form of time data function and temperature. So the first thing I have to see where is time and where is temperature. So the time is the first column, and as we can see it is in the form of year, month and day, hour, minute, seconds. So I have to use date time function to be in the same format, and my temperature is air temperature over there, which is column number 7. Okay, that's very helpful because this is how I'm gonna extract those files. So let's start with the time. So variable name, right? Variable name will be time. And then as I said, how I do extract, right now I have to pick my source, the source that I'm gonna extract from, which is will be season n. Okay, and then the cutting tools, as we mentioned before, those curly brackets. Now rows and columns. Okay, rows, I'm gonna select all my rows, which is, this is how I do select this, like double column. This means like I wanna select all my rows in this time. Okay, and as we mentioned before, time is first column, right? So I specify my rows, now I have to specify my column, which is just the first column. Okay, and I will press run. Okay, so now he's running and I have the time. but as we can see, this date time, but now I treated this as a normal variable, so I have to put this in a date time format, which let's create like maybe time, but like instead of capital it's small to differentiate between them, and then date time, and then I will put the big time. If I press run, okay, it does look the same, but it's not, because like now all my time data it's treated as the date time, so it's gonna be in a format automatically year, month, day, hour, minute, seconds. So that's very important to do this, because if you didn't do it and you like inserted in a table, it's gonna cause a lot of problems like going forward. So make sure when you're using any time data or any date like time or like formation, to always be under the function date time, and we explained date time very deeply last episode. Okay, now time for temperature. So okay, same sequence. So variable name temperature, okay, equal my source, which is season n, okay, curly brackets, select all rows, okay, and then as we mentioned before, temperature is 7th column, so number 7, and then semicolon. Run, I have my temperature here. Okay, so far so good. Now we extract both the time and temperature from the table. This is how we do extract. It's very helpful too that we do have time, because now we do understand how we can extract the time and also change it to be under the date time function. Okay, let's move forward. Next task. This kind tricky one. So remove bad data. Okay, bad data would specify that the data that has temperature more than 1000. So any temperature more than 1000 is gonna be bad data. By using find function and replace it with NaN. NaN is just abbreviation for non-applicable. Okay, so again, so I want to remove all the bad data. What's the bad data? Bad data is any temperature data that is more than 1000. How I can do this? By find function, and I'm going to replace it with NaN, which is non-applicable. Okay, so please, like as I said before, this episode is kind of practice, so feel free to pause and try it by yourself. Okay, so let's do it. Okay, so bad temperature. So first things first, I have to do variable called maybe like bad temp equal. Then I will start with find function. Find, so I use find function, right? Then MATLAB expect me to find the source that I'm gonna use find function in. So find, and then this source, which is temperature that I did extract in the previous step. Okay, and then all the bad data is the data that is more than 1000. I will make more than and then 1000 semicolon. Okay, now I do have the bad data, which is everything will be here over 1000. Okay, or bad temperature. So then I want to make the good temperature to be all my temperature. Then semicolon. So right now I just did nothing except that good temperature. Now it's the same as my temperature. I did this to now I'm gonna use subset. So subset means like I'm gonna make like good temperature. Okay, I will open brackets, I will put bad temperature, then this will be equal NaN. Okay, so what's now happening? What did I do? So now, in the beginning, I did a variable and I specify all my bed temperature with find function that I did specify all the bed temperature will be any temperature more than 1000. This is the first step. Second step, I just create a variable that equal to temperature and then the subsetting. I make good temperature, this is a bigger umbrella, okay, then a smaller scope, all the bed temperature. What is the bed temperature? Bed temperature is any temperature more than 1000 will be equal NaN. So I told MATLAB in this good temperature I wanna any temperature that is more than 1000 to be equal NaN, which is non-applicable. So this, if you wanna exclude any specific data in your own big data, you can always do this by subsetting. It's very powerful tool to use. So good temperature, bad temperature equal NaN. So if I run right now, there's no errors. Good temperature, bad temperature, NaN. So right now, my good temperature has NaN of anything more than 1000. Like everything here will be within like less than 1000 because I exclude the bad temperature, and any bad temperature will be equal to NaN, which is abbreviation for non-applicable. Okay, so far so good. Let's move forward for the next task. Okay, so next task will be use month function and find function to separate the data by season. Okay, so right now I have the task tells me to use the month function and find function that I wanted to separate data. So I want to separate data by season, which is like winter, spring, autumn, and I have to do this for all my data because like the data is season, so it has all the data that I do need for the 4 seasons. Okay, so okay, let's do the first thing using month function. Let's see how I can do this. As always, try to pause, try to do by yourself and check your answer. So first thing, so date, month, variable name, it's up to you. Be creative, it's your own style and it's your own organization. Okay, so this date month, now I'm gonna use the month function, month number or name of input date and time. So I'm just telling you I'm gonna change all this data in a form of month, which is will be numbers from 1 to 12 as like January all over December. Okay, and which data I do want? I want the data that I already changed after date time, which is already just time and time. Okay, then semicolon, or for you guys to see, now he transfer all the date time to date month in a form of 1 to 1. So yeah, 9 4 6, it will be all the months from 1 to 12. Okay, so far so good. Let's clear this. So right now all my date month is transferred to month function in a form of 1 to 12. Okay, so now let's start to using find function with for the 4 seasons. So the first season, let's start with winter. Winter will be equal, as I said, find, this is the first function. Then MATLAB do expect me the source that I'm gonna use find function in, which is date month. Okay, and I just want a specific month by itself. Okay, so winter, this require prior knowledge to know what the winter month is, which is 12, 1 and 2. So right now I want 12, and double equal, it just tells me I just want a 12. I don't want any abbreviation. I don't want 12.1. I don't want 12.2 or like 11.9. I just want a 12. So double equal just mean like I want to extract this as it is without any approximation. Okay, so the first date month is 12, and then I'm gonna do this is AND operator. So right now I want to use winter for date month 12, and then I'm gonna use date month but for 1 and date month for 2. So this is AND. So I'm telling MATLAB I want to find 12, and then I'm gonna do the same thing, date month but for 1, same thing, AND operator, date month for 2. Okay, and this is the winter. If I run now, I'm gonna have all the winter and this number of columns that has 12 and 1 and 2. Okay, so we did understand this. So double equal to extract like data by itself without any approximations. This is AND operator. For winter it's 3 months, December, January, February, 12, 1 and 2. I will do the same for the 4 season, but for time wise I'm gonna copy paste. Okay, so winter, instead of winter let's do spring. I like this because we're gonna apply everything but for 4 times. And for spring it's gonna be March, April and May, but same sequence. And also after spring, summertime will be 6, 7, 8. Then copy and paste autumn time, same sequence. So find function, then the data that I do use the find function, and I'm just changing the months. So autumn 9, 10, November. Okay, so run section. Now I do have autumn, I have spring, I have summer, I have winter. I did separate all the 4 seasons by using find function, and first I change all my date month to month function in a form of data that has 1 to 12, and I use find function double equal to extract the data and the month by itself. So far so good. Okay, now I having good temperature and I do have a bad temperature. So I need to make sure that winter, spring, summer and autumn data are all within my good temperature, not the bad one. So I have to make sure that I don't have any temperature more than 1000 at any of those seasons. Okay, so if I want to have a temperature but for winter or spring or summer, I have to make sure that I'm gonna do this like it's also subset, but that I'm telling the MATLAB that I want a temperature that it's including the good temperature but just for winter, just for summer, just for autumn. So how we can do this? This will go a long way in our code. Let's make like good temp winter. This is kind of long. Okay, so good temperature for winter. So I want to have the good temperature that has a bad temperature equal non-applicable. So non-applicable just will exclude all the bad temperature. So I want as a good temperature, I'll just subset the good temperature. It's gonna be all winter. So it's just like I'm excluding even the good temperature to basically will be just all the winter months. So any temperature here will be just during winter, during this month, which is 12, 1 and 2. Okay, then equal, here we go. Okay, I will do the same thing. Also for the sake of time, it will be the same sequence. So good temperature, but this time for spring, and instead of winter I will put spring. It's very important to see like this blue color, because this blue color means like this function matches another function in your previous like code, so or another variable, so this means it matches, and usually it has to match in order for the code to work. So if you see this color over and over, then you are on good track. If you didn't see it, you have to review your code. Okay, same thing. So instead of spring it will be summer, and I'm gonna change here summer as well. I found the blue color, so I'm good. Last one will be, what are we missing? Autumn. And then also here autumn. I find the blue color, run section, all of them I having over there in my workspace. So far so good. Now we have learned how to use month function, separate season by like data using also the month function, and then I create a good temperature for winter, autumn, summer, and all of them has a good temperature, doesn't have any temperature that is more than 1000 as we specified before. So I know this, it's overwhelming. I do enjoy the fact that we had to do this 4 times, even if it's copy paste, but it just for sake of practice, reinforcement. It's all concept, and once you get this concept, you can apply it in totally different ways. Okay, let's move forward. It's gonna be like little bit now, not like overwhelming, not at all, because it's very easy, but we're gonna use different functions. Okay, so calculate the mean, median, mode, and STD, which is standard deviation of the temperature of each season. Calculate mean, median, mode, and standard deviation of temperature of each season. So right now I want a winter, I want a winter mean, I want a winter median, I want a winter mode, I want a winter standard deviation. Okay, I know mean and median and mode and standard deviation is kind of statistics, but it's very straightforward. I don't want to explain them because I'm gonna go to mathematical like concepts, but it's very straightforward, it's very powerful to know, and it's very easy to use in MATLAB. So let's begin. So first thing, winter mean. So winter mean, we explained this before in previous episodes, so I'm gonna use the mean, which is here explanation, average or mean value of the array. So this mean, then good temperature winter, the temperature that I did create, and then I will make all, which is dimensions. Dimensions all means in everywhere, like I'm gonna say like create all the dimensions, okay, or create like specific dimension and select all dimension. So like now it's created as a one long vector instead of just x dimension, y dimension, it's all dimension. Okay, so far so good. So this all, then I'm gonna do something, omit nan. Okay, what's omit nan? Omit nan, I will leave comment here. It just exclude any nan in your function, which is last time we did specify by a find function that we have a lot of data in the bad function. Here is nan. So right now the mean, he's gonna give me the mean without any nan because I used omt nan. So right now I got the winter mean is 4.96662, which is kind of average. So sake of time, I will copy and paste, and it's basically everything like very helpful, because like even one of the big usages of MATLAB, it's big calculator, right? So that's why it's very easy to calculate this stuff. Like this stuff, in order to do in paper, it's easy to, but it's gonna takes longer time. Here it's just efficient. That's why like a lot of professors treat MATLAB as a big calculator. Right now, let's go through winter median, and also same thing, median value of the array. Okay, I have the good temperature. I'm gonna specify all dimensions on NaN to remove any NaN variables or values in my code. Okay, now I have winter mode. So mode, this is a function, most frequent values in array. Basically, in a nutshell, it's just the most repetitive value in your own array. If you have 5 ones, okay, and like 5 ones is the most repetitive values, then the mode will be 1, and so on. Okay, same sequence, good temperature, winter. Okay, and because it just mode return you like a single value, so I don't have to use all dimension or on NaN. Just in mode, because mode just return you like a singular value. So no need actually like to use all dimension. Now winter standard deviation. Okay, let's copy and paste. So winter standard deviation. Here we're gonna change some stuff. Okay, STD is abbreviation for standard deviation. OMT-NaN, I want to exclude OMT-NaN, but instead of like all dimensions, I'm gonna just have 0 value. So yeah, enter value. It will be 0 or 1. Okay, so for standard deviation, what is 0 and what's 1? So 0 is basically sample standard deviation, which is number of samples minus 1, but 1 will be population standard deviation, which will be just number of samples without like reducing one of them. Is, as I said, is very mathematical based. I won't go in depth, but I'm just telling you guys what's the difference between standard deviation between like 0 and 1, because I assume if you are using this, you probably like have to use it, or like you study the different type of standard deviation, but it's not that deep. It's just like two kind of standard deviation, whether 0 and 1, and the difference basically is with the number of values. Symbol, you're gonna subtract 1, population, it will be just number of values right away. So far so good. Okay, as I said, practice makes permanent, right? We're gonna do all the same, all of those things, but for 4 different seasons. So right now we're gonna do the same but for spring. So I'm gonna change here spring. And as I said, like it's MATLAB is very helpful. You can like really be time efficient. You can be directly capable of like finishing complex calculation in very few times. So right now just to change all the variable I do need. So spring mean, I don't need to change mean. I need to change like good temperature winter, because right now we are in spring. So I'm gonna just change this, and I do have already good temperature spring. Okay, same thing, I want all dimension, I want OMT NaN, same thing here. For the median, remove this, spring, I remove this, spring. For the mode, for standard deviation, I will do the same, remove this, and now spring. So what I want to say here, as you guys can see, it's very helpful. We can just like copy and paste and change some stuff, but follow your own lead. So if you start your own code with like writing spring as a capital, as S capital, follow all your code with spring S capital. If you write spring as S small, follow all your code with S small. This help in organization your code and help you to not like get lost for your own words. Like because this is your own words. So make your own words clear to you before anyone else, and it's very easy to follow because as you guys can see, like right now we are just editing, we are getting a lot of data in a very efficient quick time. So okay, we get spring, so we get winter, spring, let's get summer now. So summer, small, so I will do everything as a small. And as I said, I don't need to change standard deviation, mode, or median because this is all function, but I need to change this. And same applies for everything. All dimension exclude omtn. So right now I want summer. Summer. One more summer. One last summer. So far so good. One more thing. The last season for us. Autumn. 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 So basically, once you understand any concept, it's very powerful because you can apply it to one like season or something, and then you can apply it to totally different season over and over again. So as I said before, like here, it's autumn, it's A, and the rest is capital. So if I write now here, I didn't find the blue color, but now I have to write it in a form like U small t U small in order to find this. So that's why I'm telling you guys always have to follow your own lead. That's why also comments is very helpful because like for if you guys work on a big project or like a company or something, because like you're just giving tips to whoever will code after you to understand what do you mean of this or what's the tricks, because you might like find an error and you don't understand where the error came from, and then you're gonna understand, oh my god, okay, this instead of capital become small, instead of small become capital. Okay, in a nutshell, so now we editing all the four seasons, same sequence, mean, median, mode, standard deviation, and if I press run, right now I have mean, median, mode, standard deviation for all the four seasons. I know this was kind hectic, it was long, but it's very, very important to be organized in your code. I mean, today's episode, as I said, is task and answers, and part of it to be really organized, to be efficient in spelling and everything, and also like to apply different things over and over again. So far so good. Now, let's go to the next task, which is create a table with all seasons with row names are the seasons names. Okay, so we explained this before. We explained how we can create a table from scratch, and we explained how to make row names, which is just basically a function or option in table. To be the row names will be the seasons names. So let's see how we can do this. So I want a table with all seasons that has mean, median, mode, and standard deviation. Okay, let's see how we can do this. So if you guys can reference back to the last episode, I don't remember which episode, but we explained this, like it's the episode where we like created table from scratch. So the first things, as we said, for any table, it must have two rules. It must have variable names that matches the same size. Okay, so the same size, like same amount of values, and those variables has labels. So this is the two rules of any table. Variables, and it has a variable names and matches the same size. So let's do this. Now, as I said, you want to have for mean, median, and mode and standard deviation. So this is 4 different variables. So let's create variables. So all means equal. I open a matrix and then I will say winter mean. This is very important to check. And then semicolon. Okay, spring. Now I'm just targeting all means. Spring means semicolon. Autumn mean semicolon. Summer mean. I have to check it's all mean. Now if I press run, I have all means. Okay. As I said, copy, always copy and paste to save time if you can. So as I said, now I finished mean. Let's start now with median. So I have winter, but now I'm gonna change it to median. I got the blue color, so I'm good. Median. One more median. Okay, and the blue color here, so I have a summer median, summer mode, so that's why it matches. Okay, so I have the file now with all medians. Now, mean, median, mode. Okay, here we go. So instead of mean, I'm gonna change it to mode. Have the blue color, so that's good. Mode. And mode. This for all mode. One more thing finally for standard deviation, also like it's copy and paste. Now this standard deviation, and this is the biggest lesson. As I said, follow your own lead. Follow your own lead makes it super easy. It makes it like data that takes like hours basically can finish in a few minutes. Okay, so right now run. So run if I didn't receive any like red color notifications or message, then I'm good. There is no errors. And as I said, the workspace has been modified, which is mean like all those variables, like right now I can find all standard deviation, which is here, all mode, all median, all means. They are all here in the workspace created. So this means that my data is good to go. My data is correct. Okay, now let's create the table. So table variable, this variable name, not function. Now this is a function, table array with named variables that can contain different types. This is what I do want. I will open a bracket. As I said, what's the first rule of the table? Variables that has all the same size. So I have 4 variables, right? All of them are the same size, which is 4 multiplied by 1. 4 rows multiplied by 1 column. Okay, so all of them, so this is check the first box, which is variable, all of them has the same size. Then variable, all of them has variable names, which is basically all of them are here. Okay, so now we are good to go. So let's just plot them. So the first variable, here we go. So I wanna all means, then comma, all median, comma, all standard deviation, comma, all mode. Okay, and here with row names are the seasons names. As I said before, I explained this in previous episodes, so please feel free to pause and do this by your own, because they're gonna reinforce the information in your head. But as I said, now it's comma. I have options, so I can press options and row names. And then for the row names, as I said before, curly brackets is one of the best things to use in array or string array, which is character, which mean by text, which mean by letters or any characters. So right now, because I'm writing character, I use the curly brackets. I use the character brackets, which is just 1 comma. And right now, as I said, the row names is the season name, so I'm gonna write winter. Okay, same sequence. spring, winter, winter, spring, then summer, then autumn. Depend on what the order of the seasons, depend on here winter, spring, summer, autumn. That's why I follow my own lead. Winter, spring, summer, and autumn. Right now, if I press run, now I have all means, all medium, all standard deviation, or mode. Okay, the row names is seasons names winter, spring, summer, and autumn. Okay, so far so good. I know it might be a lot, like it's long episode, but this episode is basically like applying what we have studied before, what we have took in previous episodes, just to reinforcement, because I was feeling like what's the point of giving you guys in the episodes a lot of new stuff without actually practicing. So from time to time I will always stop by an episode that we can just apply what we have took before. Okay, so far so good. Today we're gonna, like, the last task is create a subplot with 4 seasons in a form of histogram. Okay, so subplot, we didn't take this before, but we took something similar, which is we explained before tiled layout. And the difference basically, like, and I said tiled layout is way more helpful and powerful than subplot. But the thing, like, subplot is still a function, is still very good to know this function, but it's really very dependent on your data. But at the same time, subplot, it might has its own advantage for the sake of like plots or graph, but it's very helpful. Like it will never hurt to know how to do the subplot, just for you to have like both skills like subsequently. So that's why I just choose today to apply like the subplot in order to see by yourself. Like we already explained, like please feel free to check the previous episode for tile layout, but I want you guys also to see the subplot and compare it by yourself. Like you can see actually the different. Okay, so let's begin. Figure 1, this will be my subplot. Okay, so subplot, basically, so MNP, what's this? So M, number of row, like number of grid rows. Okay, so I wanna, subplots will be 2 rows, number of grid columns is 2 columns, and then, okay, grid position, which is the plot position, which is 1. Okay, so what's this? Let's pause here and like explain this. So I'm telling MATLAB I want to be the subplot. The subplot, this is the entire dimension. So I'm going to create 4 subplots, and the entire 4 subplots will be 2 and 2. What's this 2 and 2? It's 2 rows with 2 columns. What this means? It's going to be 2 rows, like 2 plots in a position of row number 1, row number 2. And then 2 plots will be in a position of column number 1, column number 2. This is, okay, like right now, like in those lines, I'm gonna create a plot. The plot position will be the first plot, which is first row, first column. And this basically like the subplot. In tiled layout, we're using next tile. So instead of using next tile, we can just like write the rows and write column, and this is the first. So this basically is how like the 3 spaces like means. Okay, so far so good. And as I said, in the form of histogram. Oh my god, the histogram is just like wrong. It's histogram. Okay. So histogram plot. Okay. I want to plot good temperature. Winter. Okay, let's make it like looks neat. So let's create a title. Temperature of winter Let's create x label and y label. So x label temperature C, and y label to be maybe frequency. Frequency, the unit of it is hertz, so it's hertz. Okay, so right now, if I press run, I mean it's very too early to press run, but like, so right now, as I said, okay, the first position is in row number 1, column number 1, it's here. Okay, temperature of winter. So, and here's a subplot. The thing tiled layout was very more details, better for resolution, but subplot is kind less details as we can see, but it's still like it's the end resolution. We're gonna have 4 plots in the form of like 2 by 2, 2 rows with 2 columns. So let's keep going, and as I said, follow your own lead for sake of time. Let's copy and paste again. As I said, it's gonna be same thing, 2 and 2. Next block for me will be in a position of second row, second column. Okay, so instead of winter, now we're gonna put spring. We're gonna change just the title to spring, and this pretty much it. Okay, the third block. Okay, 2 and 2. Now we're gonna be 3. As I said, it's total 4, like 2 rows and 2 columns, right? So spring, now it's summer. I have to make sure, yes, this one, now it's in blue. Now temperature of summer, the X label and Y label are the same. Okay, the last one now is autumn. So this is the position, grid position, and now autumn, change the title to autumn. Now if I run, now I have 4 different plots in a subplot that is organized in 2 rows with 2 columns. Every one of them represent different plot for me. This representing the winter with the frequency and temperature, representing the summer with like frequency and temperature, representing the spring, representing the autumn. It's all in subplot. As you guys can see, like this is a subplot. You can reference back to tiled layout. The difference between them, as I said, just resolution and how far or what's your tolerance to make your data clear, or how picky you are to make your data, whether it's very clear or not that clear, or you don't care. Might be like here it might be helpful in some points. A tile layout might be helpful. Actually, like it really doesn't hurt to know both and to choose whatever will work for you, whatever you can explain better, because like at a lot of times, as I said, if you are working on like big project, you might understand different codes, but like you might choose a famous one in order for the next like programmer not like to like struggle after you. So you have to keep this in consideration as well. Okay, so right now, finally, it's time for our mini assignment. And today, our mini assignment will be basically going through the episode several times so you can see the task and the answer. But the mini assignment is basically go like read every task and then pause the video, do it by yourself, and then see how did I do every single time with every single task. Do this, pause, okay, do it by yourself from scratch, and just see yourself how good or bad, like correct yourself, because basically you have the questions and the guide answers and how you can do this. And also one of the big thing I also mentioned before about this episode, that it's 4 seasons, so basically you're applying everything for 4 times, which is kind of like reinforce everything in your mind. So now we have reached to the end of our episode. Make sure that you did right and tried everything by your own. Feel free to do the mini assignment as I said earlier. Leave comments for any questions. So as always, programming about practice, and practice makes permanent. Thank you all and see you all next episode.